All right, here's another one. Hi everybody, hope you're doing well. This is going to be a lesson that covers chapter 6.6 in the textbook, specifically arithmetic series, not sequences. Partly, it's going to be similar to sequences. That's why we have arithmetic, but series is slightly different. Please, in the future, if you get some kind of question in a test or a quiz or a problem set, make sure you identify whether it's an arithmetic or geometric sequence or a series, because how you approach it will be a little bit different. It's very important that you get that clear. All right, disclaimer given. Arithmetic series is, by definition, I'll type it out because, it is, after all, definition. Let's see. By definition, the sum of the terms in an arithmetic sequence. The sum. That's it. That's all it is. But again, that doesn't mean much to a lot of people, so let's do some examples. Disclaimer again, this one's going to be a bit of a long video, and if I make mistakes, I don't think I have the actual time or the ability to go through it perfectly without mistakes. So if I keep on making mistakes, please bear with me and follow through. Here's my example of how arithmetic series is a little different than what we've done before. So arithmetic sequence, what we've done in the past, will be something like this. Let's say 3, 7, 11, 15, 19, and 23, and so forth, right? From here, you know that the first term is going to be a 3. And so instead of T1, we like to write it with the letter A. That's going to be a 3. And then how do we calculate the common difference between the terms? Well, you could do 7 minus 3. Hey, that's a 4. 11 minus 7, hey, that's a 4. 15 minus 11, hey, that's a 4. All of these shows that the common difference is going to be a positive 4. So bringing these together, how can we put it up? Put it in a formula. Tn is going to be, as I hope you remember, n minus 1 times d. And so that's going to be 3 plus n minus 1 times 4. Okay, that is enough. This formula is enough and you can stop there. But if you do want to simplify it, by distributive property, this becomes 4 times n and negative 1 times 4. And if I simplify that, it simply becomes this. Either or is okay. All right? An arithmetic series, so I'm going to take the same sequence, but write it as a series. A series, as we said before, is the sum of the terms in arithmetic sequence. So it is basically 3 plus a 7 plus an 11 plus a 15 plus a 19 plus a 23 plus so on and so forth. It basically keeps on going. And the number that you're adding is larger than the previous number by the common difference. Okay, so if I were to add it, it gets a little bit more complex quite quickly, right? So the 3 in itself is just that, but the 7 is what? 3 plus a 4, right? And the 11 is a 3 plus a 4 plus another 4, right? And then the 15 would be so on and so forth. If I were to add it up, how many times are you adding the a value? The first term, that would be 12, right? How many times does the d value get added? Well, that would be 6 times, right? 3 and then 2 and then 1. It gets a little bit out of control. Okay, how do you even bring yourself to create a formula? And the reason why I bring up the formula is, let's be honest, mathematics, if there is a pattern, there is a formula or an equation that can help explain or help get the final answer faster. Bottom line, if there is a pattern, there must be a way. And if you take a look at this, this is a 3, and then the common difference is added once, twice, 3 times, 4 times, 5 times. There is a pattern. It's difficult, but there must be a pattern. So how? Well, this is why this video is gonna get a little bit long. I do want to explain to you how the formula is. So before I actually get to it, some of you will not be interested in how the formula is derived. I am just going to give you the formula, and then you can use a timestamp on the bottom just jumping to the examples that we do as practice, okay? Others, please stay tuned after I write this formula, and I will show you where this silly thing came from. The total, the sum of the series, okay, with a certain number of terms is equal to n divided by 2, bracket, a plus the very last term. That's it. Another way you can write this is, because we know that a term number is defined as a plus n minus 1d, you can say that Sn is equal to n over 2 a plus n minus 1d, which is going to be n over 2 2a plus n minus 1d. Okay? I'm going to explain a little bit more afterwards, but just to let you know, this could be one formula, and this could be another formula. They are virtually the same thing, but depending on what the actual question gives you, the information that the question gives you, you might want to choose one over the other. All right, so let's talk about where this formula came from. I am going to clear everything, and yeah, so if you want to copy something down, you might want to pause the video and do so. Otherwise, I'm just going to do a full clear. Before I forget, please, textbook questions are there, page 400, numbers 1 to 3, 5, 7, 9, 11, and 13. Something that you want to try practicing after we go through the video. And clearing in 3, 2, 1. There we go. So where did this formula come from? Well, to actually, as the story goes, Carl Friedrich Gauss, so a German mathematician, where the math contest is named after. So if I remember correctly, Carl Friedrich Gauss, okay, was I believe the person that sort of experimented or came up with this, as the story goes. One day, once upon a time, as a young boy, I guess he was being annoying to his math teacher, and math teacher just wanted to keep him busy. He told Carl, or Gauss, to add all the numbers from 1 to 100. Every single number. So it's literally 1 plus 2 plus 3 plus 4 plus 5 plus 6. Literally 1 plus 2 plus 3 plus 4 all the way to 99 plus 100. Looks like an arithmetic series, right? Well, how the heck did you do that, right? Just kind of muscle through? Well, that's what the teacher thought. The teacher's like, this is going to keep him busy. It's going to keep him off my back. After only a few minutes, Gauss came back to the teacher. He's like, okay, I'm done. What's next? So how do you do that in just a few minutes, right? I'm assuming that they didn't have a calculator back then. All they had maybe was an abacus. I don't know. Here is the magic of Gauss's creativity, which sort of gave birth to this formula. Okay, so let's take a look. Let's sort of experiment it. This is something that you might want to do this is something that you might have done if you were given this task, right? The sum of the first term was just 1. The sum of the second term is 1 plus 2, which is 3. The sum of the third term is 1 plus 2 plus 3, which is 6. Sum of the fourth term is 1 plus 2 plus 3 plus 4, which is 10. And that's already annoying. Hey, by the way, shameless plug, 1, 3, 6, 9. sorry, 1, 3, 6, 10. Does that look familiar? Yeah, going once, going twice. Pascal's triangle. These are, I believe, the triangle. Anyways, so okay, so did he actually do this all the way up to the 100th sum of the series? Probably not. He actually didn't force his way to calculate the sum of all 100 numbers. He just used his brain. Something that we should all be doing. Always approach a problem with brain and not wrong. Okay. Consider this series. Okay, I'm going to rewrite this series intentionally and extend it just a little bit. What if I had 1 plus 2 plus 3 plus 4 plus 5 plus 96, 97, 98, 99, and 100. Okay. Take a look at the first number and the last number. What does that equal? 1 plus 100 equals 101. Please take a look at the second term and the second last term. What does that add up to? 101. Please take a look at the third term and the third last term. What does that equal to? 101. I think you get the point. The question next is, how many times can we create 101? How many times? How many 101s can we make? The answer is 50 times, right? Because the first and the last term and the second, the front and the back are constantly paired together. How many pairs can we make? Where there's 100 numbers in total, if I make pairs, that means I'm essentially cutting that in half. So I'm going to make 50 pairs. So what's the actual total? Well, it's going to be 101 times 50. That comes to 5050. That would be the sum of the numbers from 1 to 100. Pretty fast, huh? All you really need is basic arithmetic to actually solve this question. And so, yeah, that's what happened. And to derive the equation, here is the final explanation. Quick eraser. I am going to ask you to take the series from 1 to 100, and I'm going to get you to write it twice on your paper. Okay? So again, same thing with this. I don't need all of that. I'm going to rewrite it. All right. So by definition, the sum of the series from 1 to 100 terms is 1 plus 2 plus 3 plus 4 plus 99 plus 100. Oops. Okay. I'm going to get you to write it again underneath, but do it in reverse. 99 plus 98 plus 97 plus 2 plus 1. And like addition in elementary school, I'd like you to add. If you have the sum of 100, whatever that is, plus another sum of 100, whatever that is, that would be twice the sum of 100. And if I were to color coordinate and simply just add top and bottom, every single one of these pairs is going to create 101 plus 101 plus 101 plus 101 plus 101 plus 101. I have 100 101s. Okay, let's just do that really quickly. 100 101s is equal to that, which is 10100. So if you actually want to get the sum of 100 on its own, you divide both sides by 2 and you get 5050. Okay? Yeah. And so if you were to do that another way, so take a look, this part right here. Another way we can actually describe this is if you have 2 times the sum of the series up to 100 terms, that's basically saying 1 plus 100, 100 times. Another way you could say it is it's the first term and the last term times 100. And of course, to get it to on its own, that is the first term and the last term divided by 2, that's going to be 50. But for the sake of formula, let's just do that. Starting to look familiar? Please note, you're not going to know if it's 100. What if it's 50? What if I want to know the sum of 67 numbers? What if I want to know the sum of 1,000,000 numbers? So as a general formula, the sum of n terms is going to be the first term and the last term divided by n over 2. And just as a little pointer, whatever n is, that's going to also be this n, and of course also be that n. It's going to be matching. But if you remember the prior to, before I gave you this explanation, there was another formula you can do. And as a reminder, Tn from your arithmetic sequence lesson is the first term plus n minus 1 multiplied by d. And so if I were to rewrite this, I could technically rewrite it as 1a plus n minus 1d multiplied by n over 2. And if I simplify it, 2a plus n minus 1 d times n over 2. When would you ever use the first formula? Well, think about it. If the question gave you the first term and the last term already, so a and tn. If the question gave you those two already, it's so easy to use the first formula. When would you use the second formula? Let's pretend the question didn't give you the first term and the last term. However, the question did emphasize or give you clues of what the d value is. Right? You don't know what the first term is, but you don't know what the last term is, but you know what the d value is. Well, then you would use the second formula. Either way, what do both formulas absolutely need? Both formulas still absolutely need the n values. Okay, so first formula, second formula, there are times when either one of them is more helpful than the other, but both of them, you need to be able to calculate the n value, and you'll find that your knowledge from arithmetic sequence will come in handy. Shall we do some questions as a review? I hope you said yes. I'm going to give you a bunch. You might want to use timestamps or maybe pause the video and try them yourselves or copy it down, whatnot. I'm going to be clearing this, so pause the video to finish your copying, and in 1, 2, 3, there we go. Let's do this. Here is a simple example. Okay, example. What is the sum of the series 3 plus 8 plus 13 plus ... plus 58? A very straightforward, very simple question. It might seem hard at first, but again, once you get used to it, you'll find that this is as easy as it gets. Okay, let's declare a couple of things. That is the first term, a equals 3. This is the last term, Tn. I don't know what n is, but I do know it's 58. And using this, you should be able to calculate d. Okay, So choose either of the methods because you'll find that you can't actually do it right away. Okay, so let's do method one. Let's use the first formula because the last term is given. You may think, okay, the last term is given, and Mr. Kim said that in the video, if the last term is given, I can use this formula. All right, let's do it. So Sn equals n over 2. The first term is 3. There's thing. I don't need the d value. Okay, so what is it? I don't have n. Okay. Well, maybe the other way might work. Okay. Mr. Kim said if the first way doesn't work, maybe the second formula will be useful. Well, try it. 2a plus n minus 1 d. That's the generic formula. N over 2. 2 times 3 plus n minus 1. The d value, it seems like it's increasing by 5 every time, so the common difference must be 5. I still don't have n. So how do you find n? This is why your knowledge of sequences is going to come in handy. When we have an arithmetic sequence, the formula is a plus n minus 1 d. It's not the sum, it's just a single term. How to calculate a single term, not the series, just a single term, is based on this formula, and we know every single one. We know Tn, or the last term, is going to be 58. We know the a value is a 3. I don't know what the n is. I don't know actually how many terms there are in the series, but I also have the d value. I have everything. And once you plug it in, you realize I have an equation with one unknown, sort of like an x value. I am going to go about finding it. Minus 3 on both sides, 55 equals n minus 1 over 5. Divide both sides by 5, 11 equals n minus 1. Add 1 to both sides, 12 equals n. There are 12 terms in this series. So let's plug it in. Method 1. Since we have n, sum of the 12 terms in this series is 12 divided by 2, that creates the 6. 3 plus 58, which is 6, 61, 366. If I chose method 2, sum of the 12 is 12 over 2. 2 times 3 plus 12 minus 1 times 5. I'll pause. Sorry, 1 second. Maybe I won't pause. I'll just finish this off. 6 times 6 plus 11 times 5. 6 times 6 plus 55. 6 times 61, which is 366. You get the same answer. All right. I'll pause right there while people are probably trying to copy this down. If you're wondering where the heck I got those formulas from, remember I already calculated the formula for method 1. So all I had to do was plug in the number. If you're wondering where the heck I got the other one, remember for Sn, for method 2, I already calculated everything. All I needed to do was plug in what the value of n was. Okay. Sorry if that wasn't clear. I must have rushed it. I'll give you a sec to copy it. If you don't have enough time, please pause the video and let's work that out. I will be, pause it now because I will be clearing the screen in 3, 2, 1. Okay, last one. This should be enough to be last one. Page 399, example 4. I think it's a good one because it's a word question. I'll give you a chance to open your textbook to see it. Long story short, we are comparing payments. One person is going to be paid $7 an hour for 20 hours. Okay, that's way, way long time ago, I guess. Minimum wage is double that, right? Another person is going to be paid $4.75 for the first hour, but they get paid $5 for the second hour, and then $5.25 for the third hour for 20 hours. So there's going to be 20 numbers there. Okay. Of course, the last term is not given here. Can you find it? Yeah, absolutely. Just start adding the D value 19 times, right? What is a D value? I'm hoping you can tell. It's 25 cents. Let's calculate. What is the total for the first type of payment? Well, it's $7 per 1 hour multiplied by 20 hours. Cross the units. I have 7 times 20, $140. This person will be paid $140 flat. It's a linear relationship, whereas this one is not so linear. Okay, what is the sum of the 20 terms, the sum of the series? Let's work it out. Do we have the A value? Absolutely. Do we have the D value? Absolutely. We don't have Tn, but we do have the n value being 20. So I am going to say that the slightly longer formula, n over 2, 2a plus n minus 1d, is going to work. Sum of the 20 terms is 2 times $4.75 plus 20 minus 1 times 25 cents. That's 10, $9.50 plus 19 times 25 cents. $4.75. We'll put that together. If my calculations are correct, $142.50. So between those two, wow, all that math for an extra $2.50, right? Yeah, it seems a little excessive, but know that if we can calculate something of this small magnitude, I'm hoping you are convinced that you can also apply it to values of larger magnitudes. It might seem like a bit of an overkill, but you will see how our next lesson on 6.7 is absolutely important, especially if you are going into any kind of field that involves finance, or if you're looking to do some kind of investment, especially if you're, let's say, when you get to my age, you may feel actually be already too late if you haven't started investing yet. Stay tuned. But for now, let's take it at baby steps. Your homework, please try page 400, numbers 1 to 3, 5, 7, 9, 11, and 13. Ask me questions, send me emails to pull all doctor stops. Make sure your understanding is clear before you move on. Best of luck. Hope to see you soon. Take care, stay healthy, and don't stop trying. Bye.